View components are a brand new feature for views in ASP.NET Core. At their heart, they replace child actions. Now, the simplest way to do reusable content in classic ASP.NET were these child actions. These were controller action methods decorated with the child action only attribute, and it was called from within a view or layout file. But they had some problems. For one thing, child actions don't support asynchronous programming. And then another big problem with them was the use of the authorize attribute, which you probably applied intending for it to apply only to the child action, so that that little chunk of content wouldn't appear on pages for users that weren't logged in or didn't have a specific role or whatever the scheme was that you set up. But the problem is that when you applied that attribute to a child action, it suddenly applied to the entire view. And that triggered a nasty infinite redirect. Gadzooks. So there's some problems with child actions, even though if you use them carefully, they were pretty nice, pretty slick feature for creating reusable content, at least within the context of a specific controller. View components are also kind of similar to partial views. Partial views are fine if the widget doesn't require any interaction with the server, such as if all of its data was already part of the parent view's model. So what's happening here is that view components are a better alternative to both child actions and partial views. And in fact, child actions had so many problems that they're not even a part of ASP.NET Core anymore, so they're not even an option for you to use. Now, what's interesting about view components is that they don't participate in the controller lifecycle and pipeline. So there's no action filters. You can't filter on the action methods that happen and so forth. And that might seem like a bit of a problem, but action filters on their own caused a number of problems in classic ASP.NET as well. View components also don't have model binding, at least to the parent's view model. Essentially, it gets its own set of data. So, bottom line is that the behavior of a view component is similar to that of a controller in a view, but without the problems that are caused by child actions or the limitations of partial views. Okay, so a few other things about them is that they don't use model binding, but do depend upon the data that you provide. So you can provide data to the view component and then be able to use that as part of the processing of that data, because view components do have the ability to implement business logic. They're similar to a view, but they render only a bit of a page, not the whole thing. So keep in mind that you're not going to use a view component to display an entire page's worth of data. You can kind of do that, but it's a corruption, and it's really not the best way to do things, because controllers and views are fine for entire pages. Nice thing is that it is similar to conceptually how they work, or similar to controllers and views. And so it has the same separation of concerns as a controller and a view. So the view component class has business logic and comes up with model data or any other kind of data that you're going to use within the view of the view component. But it doesn't go through the entire life cycle of a controller and a view. Now you can pass parameters. As you're going to see, you invoke the view component from within a view. You can also do it from within an action method, but that's a little bit more rare technique, but it is possible. But because you invoke it as a method, you can pass parameters and then implement business logic based upon that. And a little bit later, both examples do that I'm going to be showing you. Okay, and as I mentioned, they can be invoked from a view or an action method in a controller. Now, an important other thing to understand about view components is that they consist of two parts. The class, which is typically derived from view component, which I'm going to talk more about later, because you have a lot of flexibility in how you define a view component. And then the second part is the result that returns, which is typically a view, although you can return a string or an HTML string as well. Like controllers, a view component can be a plain old C# object, POCO. But most of the time, again, you'll probably want to take advantage of the methods and properties available by deriving it from the base view component class. And I'll talk more about that and why you might want to consider doing that for probably most of your view components. Not always, but for most of them. So how can you use a view component? Well, there's a few suggestions that Microsoft makes, but the bottom line is that consider using a view component when you have reusable rendering logic that's too complex for partial view. Partial views are still part of ASP.NET Core. They have a place. They're still useful. View components doesn't completely replace them. But keep in mind that they do completely replace child actions. Okay, so you could use it for dynamic navigation menus. I really kind of like this one that I implement a lot of times in my sites, because when users log in, or when you have an authentication system in place so that users can log in, oftentimes you need to present different menu items based on either whether the user is logged in or not, or if they're part of a particular role. And so a view component is a great way to encapsulate that kind of logic based on the properties of the view component. And in fact, if you inherit from the view component method, you get access to the HTTP context as well as the user information, so you can make those kinds of logical decisions within the view component code. You can also use it for a tag cloud, where you go in and hit a database and do some sort of analysis and summary and come up with a tag cloud that you display in various places on your page. I mentioned the login panel that has a login button when the user's not logged in, and then a log out button, the user's name, maybe a link to a profile or other features that essentially modifies itself based upon whether or not the user is logged in. You can also use it for a shopping cart, to display a shopping cart and say that you have 5 items within your shopping cart and they total $1,322 or whatever you want to display as part of that shopping cart, or even a summary of the shopping cart. A very common use is for recently published articles. If this is a news site or a blog site, then you can come up with a list of recently published articles, or most popular ones, or maybe a summary of articles in some fashion based on time or whatever. And so you can do that and then put it in various sidebars and widgets and so forth. And in fact, sidebar content is a typical place where you'd use a view component, because you're going to use that in multiple pages throughout the site. Okay, and redundantly, a login panel that's rendered on every page. So the bottom line is that you should consider view components when you have content that's repeated in multiple places in a site, whether that multiple places is on different pages or the same page repeatedly. And in fact, my second example I'm going to show you is that I use the view component 3 times on a single page, but because you can pass it a parameter, you can customize what exactly is displayed. And so you might have different summaries of some sort of data that you display multiple times on the same page. Okay, so let's talk about how you create a view component class. There's 3 ways to identify a class as a view component. The first way that I've mentioned is to inherit from the view component base class. And then the second way is that you can just name the class with the view component suffix. For example, the tags view component for maybe a list of a tag cloud or something like that, or a summary of the tags that are available on your site with links to all of the blog posts with that tag applied, whatever it might be. But the important part is that here the name of the view component is tags, and that's what you use within your code. But you name the class tags view component, and then ASP.NET Core identifies that as a view component and knows what to do with it. Doesn't have the benefits of all of the features that are part of the view component base class, but you don't absolutely have to use those. If you don't need those features within that particular view component, you don't need to use them. And so this is a convention. Just include the name of the class tags view component. And then the third way is that you can decorate the class with the view component attribute. Or similarly, if you inherit from a class that has that attribute on that base class. Okay, so you have all these options. But like I said, most of the time you're generally going to want to inherit from the view component base class. That way you have nearly all the same functionality as a controller, including things like viewbag. So you can use a viewbag to pass data back and forth. You can get user information with the user property, so you can find out what role they are and whether they're logged in and so forth. You can also access route information. That's part of the bundle of properties that the view component base class includes. You can also get information about the request from the request property. That essentially exposes the HTTP context object, and then various other features. Okay, and sort of as I alluded, ViewBag is shared with the controller. So that's one way to communicate between the controller and the view component to share data. It's a little bit of a coupling between the controller and the view component, but you can work around that. Okay, and then the nice thing about using the view component base class is that you can then attach your custom component to a Razor view and just call the view method and with various parameters, and we'll look at a couple of those options. So again, most of the time you want to inherit from the view component base class. Now, as with controllers, your view component has to be public, must be non-nested, and a non-abstract class. You need a concrete class for ASP.NET Core, the runtime, to instantiate and do whatever it is that your view controller does, or view component does. Okay, then as I mentioned, but very important, the name of the view component is the class name less the suffix, okay? If you use that convention, if you decorate it with the view component attribute, you don't have to include the view component suffix, in which case the view component name is just the name of the class. Okay, alternatively, you can set the name property of the view component attribute. So you want to name a class something different, but in practice in your site, you want to use the view component with a different name. Just use the name property of the view component attribute. And a nice thing about a view component is it fully supports constructor dependency and injection, so that you can inject, for example, an object context for an entity framework model and be able to access data from the database or a data store, or any other kind of services that you need within the view component in order to generate the content for the page. And again, doesn't take part in the controller lifecycle, which means you can't use filters in a view component. Okay? So again, not really a problem. It seems like it would be a problem, but you have control over when the view component is invoked. So I've never felt like lack of filters was a problem, so far anyway. Okay, so within the view component, you have to define a method, and the name of the method is invoke async. Now, a big caution. Pre-release versions of ASP.NET Core included an invoke method as well, not invoke async, but just an invoke method. That was dropped before the initial release of ASP.NET Core, but you'll still find documentation and online articles that reference it. So it's just not there. Don't look for it. Just be aware that that might be a little bit confusing. Now, the method usually returns an iViewComponentResult object. But that's not absolutely necessary. It can also return a string or an HTML string and some other things. But usually it's going to return an iViewComponentResult object because most of the time you're going to use a view in order to display the content of the view component. And one nice thing about the way it's invoked is that you can pass in parameters directly from the invocation, not from model binding. It doesn't buy into the model binding of the controller or the view that you are invoking it from. So that's if you're used to using other forms of reusable content in classic ASP.NET, that may take a little bit of getting used to, but it's actually kind of liberating. It really makes the view component a standalone reusable component. Really reduces the coupling, which most of the time that's just fine. Okay, now typically it's going to initialize its own model and passes it to a view by calling the view component's the object's view method. And again, that's only available if you inherit from the view component base object. And it's also important to understand that it never directly handles an HTTP request. Never. So, in other words, a view component isn't reachable from HTTP directly. So you can't call it from client side. If you need to do that, what you want to do is wrap it in an action method, and I'll show you how you do that. It's really very straightforward. And so then you can integrate them, and then view components kind of start acting like child action methods, but they're really not. They're still quite different. Okay, and then you can overload the invoke async method but it's not overloaded by the very nature of an HTTP request. Okay? So you have a lot of flexibilities in how you handle that method and define it. All right, then the last piece of the puzzle is using the view component. Now, when you call for the view, what the runtime is going to do is it's going to search for the associated view in two paths. And keep in mind, this only applies if you're using a view component's view as part of the view component. And that's what I do in both of the examples, because I think that's going to be the most common usage. So the first place it looks is under Views, the Views folder, same place as where your controller's views are, Shared. And then you have to have a subfolder called Components. And then a subfolder with the view component name. And again, if your class name is called Tags View Component, then VC name here would be Tags. So it's the name of the class dropping the suffix if you use that view component suffix. And then you have the view name. And then the second alternative is that if you have a view component that is specific to a controller, you would put it in Views controller name, Views home or whatever the controller name is. Components again, has to be components, and then the view component name, and then the view name. Okay, so again, the difference between these two options is that the first one, under Views Shared, those are for view components that are shared across all views within the application. And then the second one is for view components that are used by just a single controller. Now, typically, you won't use the second option, but it is handy if you have a different view for the same component depending on the controller that owns the current action method that caused this view component to be invoked. And that's kind of a convoluted case. So normally, you'll want to use the first option so that view components are used throughout the application. But if it's used in just a single controller, feel free to use the second one. And the runtime will take care of searching in those places and find the right thing. Now, the default name for a view component view is default. So it looks for default.cshtml. Now, you can specify a different view name. So it can be floyd.cshtml. But then you need to provide that custom name when you call the view. Okay, so you just pass it into the view method. Okay, so the first way to invoke the view component is directly from within a view, and this is the syntax that you do. So I'm going to use await, it's asynchronous, component.invokeAsync, and then pass in within a string the view component name, and you can optionally include an anonymous type that has the parameter values that you want to pass to that view component. You have to have defined those parameters on the invoke async method that you define within the view component class. And so you just new up and say, if you have a property called name, you set name equals Floyd or whatever. Now, another thing about the syntax is that the first parameter there, VC name, that I'm just using, it's whatever the view component name is a string, but you can use the C#6 operator name of in order to make essentially a strongly typed component. So the debugger can validate that there is in fact a view component with the name that you specify. So you have that kind of option. Okay, and then you can also invoke it from a controller action method. And this would be the syntax. So it would be return view component. So again, this isn't from within the view component code, it's within an action method of a controller. So you return view component, and then the same, provide the name, you can use name of again, and then provide an anonymous type with properties for each of the parameter values that you want to pass in. And you can make the parameters optional and so forth. And just keep in mind, the properties of that anonymous type need to match, the names of the properties need to match the names of the parameters, because that's how the runtime matches the values up to pass them into that method within the class. And you can again use the name of operator there for the first property that you pass to the return view component statement. Okay, so let's do a quick summary of view component advantages. You have the same separation of concerns with a controller and a view, which is really nice. You can write clean code, particularly because it's reusable code that you're using throughout the application. You can invoke it with parameters, so you can customize how the view component does its work. Or you can have the view component just detect its environment, read data from a database, whatever you want to do in order to make this flexible for use throughout an application. It supports business logic, so you can write as convoluted logic as you want. You can invoke different business logic components that you have within your application. You can go hog wild. Doesn't use model binding. Specifically, it doesn't hook into the model binding of the parent controller. It's invoked asynchronously, so it has all the goodness of asynchronous coding. Can use dependency injection, so you can inject any services. And then doesn't participate in the lifecycle of the controller, which is really a benefit because you don't have to have the whole overhead of a controller running anytime you invoke a view component.